Here's the first video of the year. This is Unit 1-2, and our objectives for today are the student will be able to write functions representing translations and reflections, write functions representing stretches and shrinks, and write functions representing combinations of transformations. So, the first thing we're going to start with is translations. Now, translations are slides. You can slide them up, down, you can slide them at angles. But to start with, we're going to work with horizontal translations. And horizontal translations will be this way. A horizontal translation, anytime it's horizontal, it just affects the x. Whereas vertical translations are up and down, and they affect the whole function. So those will be outside. So that will be the difference. If it's inside the parentheses, you'll know that it's just affecting the x, and it's a horizontal translation. And if it's outside, it's vertical. Also, if h is greater than 0, then the graph moves to the right. Now, where you have to be careful on this is when it says x minus 3, h is really 3 because it's x minus. So if you always think it's the inverse of what it says. So in this case, it's additive inverse, so it's the opposite. It says minus 3, so it would be plus 3, so it would be 3 to the right. And then if it's negative, x plus 7, that would be 7 to the left because h would have to be negative 7 to get x plus 7. Because if you write this, it'd be x minus a negative 7, which a negative, negative, remember, change both signs, and it becomes x plus 7. So that's the biggest mistake people make, is it's always opposite what it says. So this one would be 3 to the right, and this one would be 7 to the left. Vertical translations, again, are up and down. So this k is outside, it affects the whole function. So if k is greater than 0, the graph moves up. So this would be if, let's say it was x minus 3 plus 7, that would be 3 to the right and up 7. So it affects the whole function. If it's less than 0, it moves down. So if it said minus 7, it would be 7 down. So those are horizontal and vertical. Again, horizontal affects just the x, vertical affects the whole function. So if we look at page 12 in the book, so example number 1, it says let f of x be 2x plus 1. So this is our original function, 2x plus 1. So it says write a function g whose graph is a translation 3 units down. Well, 3 units down means it affects the whole function. So if we were to write this, we would take 2x plus 1. It's going to affect the whole thing, so we put parentheses around it. And 3 units down would be a minus 3, which you can see they put the function. Another way to write it is the function minus 3, so they've written it that way. Then we should simplify. So this would become 2x plus 1 minus 3. So our final function would be 2x minus 2. And that's the function g. So if we were to write this, it goes to g of x. So we would write g of x equals 2x minus 2. Okay? Now, you can write functions. They usually have f of x for function, but we have to have different labels. So usually they go f, g, h, but you can use anything you want. It could be I of x, but most of the time they'll use f, g, and h for functions. So the second one says write a function h whose translation is 2 units to the left. Well, remember, 2 units to the left, that's horizontal, so that affects just the x. So we go 2, affects just the x. So now we go, it's to the left, but remember it's opposite what it says when we write it. So that would be x plus 2. And then we have the plus 1. So again, because it's horizontal, it affects just the x. So we put it in parentheses. And then we simplify that. So we would distribute the 2. 2x plus 4 plus 1. And so our h of x would become 2x plus 5. So you just have to be careful on those. Again, if it's vertical, it affects the whole function. Horizontal, just the x. So if we go back to our notes, now we're going to do reflections. Reflections can be in the y-axis. We can reflect it if we've got a graph. This is our x-axis and this is our y-axis. So if we reflect in the y-axis, that means we're going to reflect it left and right, which is horizontal. So again, that affects just the x. And all you have to do with reflections is you use a negative sign. Okay? So when it's horizontal, since it affects just the x, we put the negative sign with the x in parentheses. And if it affects the whole function, we put the negative sign on the outside. And so that would be negative f of x. So again, if we go back to the book and we look at example number 2, it says, let f of x equals x plus, the absolute value of x plus 3 plus 1. And it says, write a function, g, whose graph is a reflection in the x-axis. So in the x-axis, that's up and down, so that would be vertical, so it affects the whole function. So we would take the whole function, and I'm just going to put that in parentheses, and we're going to take the opposite of the whole thing. So if we were to simplify that, the negative sign affects this. Now what you don't do is you don't take the negative sign into the absolute value, because we have to do that first. So it would just become negative absolute value of x plus 3. And then it does affect, it's going to both of these, so it affects the 1, so it becomes minus 1. And you would just leave it like that. The book goes through, I would just leave it like that right now. The book, as you can see here, what they do with absolute value is they split this up and then distribute that. But right now, we're just going to leave it in this form right here. You don't have to simplify that further. Okay? Then on B, well, that's the next case. So that's there. In B, it says, write a function h whose graph is a reflection in the y-axis. Well, reflection in the y-axis, remember, this is my y-axis, so that's horizontal, so now it just affects the x. So we take this function again, but now it affects just the x, so we put negative x plus 3 plus 1. Because it doesn't affect what's outside. And that would be our h of x. Now this is where the book simplifies it, but we won't go ahead and do that. They pull a negative sign out. We'll just leave it like that for now. You can change it when you put a number in for x. So what I'd like you to do right now is try these monitoring progress. It'll just be MP on the notes. But I'd like you to do 1, 2, 3, and 4. So go ahead and pause the video here, do these problems, and then you can come back and check it. I'll go through them, and you can see how you should have done them or to make sure you get it right. So go ahead and try that. All right, so your answers on this, we've got f of x equals 3x, and we want to move it 5 units up. So up is vertical, so it affects the whole function. So for number 1, you should have just taken the whole function, 3x, and added 5 to that. And so to simplify that, we would get 3x plus 5. Now again, they ask you to write these as g, so technically that would be g of x equals 3x plus 5. Number 2 is a translation 4 units to the right. So to the right, that is horizontal, we do the opposite of what it says. So now we're going to take this, and when we come to x, so number 2, you should have come to x. 4 to the right, we do the opposite of plus 4, which would be minus 4. And then absolute value, minus 3, and we can't simplify that any further right now, so that would be our g of x. Then on number 3, it is, we're going to reflect it in the x-axis. X-axis is vertical, so it affects the whole thing. So we're going to take the whole thing, which right now is negative absolute value of x plus 2 minus 1. We're going to put that in parentheses and put a negative sign in front and then distribute. Again, the negative and negative becomes a positive, so this just becomes the absolute value of x plus 2. The negative affects the minus 1, that becomes plus 1. And so we get g of x equals the absolute value of x plus 2 plus 1. The last one was a reflection in the y-axis, so I'm just going to put this right here. So again, that's 1/2 x plus 1. Since it's in the y-axis, it is horizontal, so it just affects the x. And then to simplify that, 1/2 times negative x would be negative 1/2 x plus 1 equals g of x. So hopefully you got those all right. So if we go back to our notes, so this was where it says do MP 1 through 4. That's, you're going to go through and do that. Next thing we're going to look at is horizontal stretches and shrinks, and vertical stretches and shrinks. So again, what we need to understand, anytime it's horizontal, it affects just the x, and anytime it's vertical, it affects the whole function. So this says f equals a times x. Because it's inside the parentheses, it's horizontal. Okay? And to tell if it's a stretch or a shrink, it's a horizontal stretch or shrink by a factor of 1 over a. So just like we did with horizontal translations, remember it's the inverse of what it says. And so because they were added and subtracted, those are additive inverses or opposites. With horizontal stretches and shrinks, since it's multiplied, it's the multiplicative inverse, or the other word for that is reciprocals. So it's a horizontal stretch or shrink by a factor of 1 over a. So it's always the inverse of what it says. So if this said 3x, then it would be 1/3. If it said 1/5 x, then a would be 5. So this is the value of a, is the inverse of what it says. And so if a is greater than 1, so in this case a is greater than 1, that would be a horizontal stretch here. Okay? And because a is less between 0 and 1, it's a horizontal shrink, and so this would be a horizontal shrink of a factor of 1/3. Now, the reason we don't worry about the negative sign, because remember the negative sign is the reflections. So we don't worry about that, it's just the absolute value of a is all we care about. With vertical stretches and shrinks, then it's outside, so it affects the whole function. So it is a vertical stretch or shrink by a factor of a, so now a is what it is, just like with vertical translations. So if a is greater than 1, it's a vertical stretch, and if it's between 0 and 1, it's a vertical shrink. So if we look in the textbook on example number 3, so example number 3 says let f of x equal the absolute value of x minus 3 minus 5. Write a function g whose graph is a horizontal shrink of the graph by a factor of 1/3. So horizontal, remember, tells us it's going to affect just the x, and it's going to be the inverse of what it says. So it says by a factor of 1/3. So instead of x minus 3, our a is really 3, so we're going to put 3x. It just affects the x, so we don't, doesn't affect the 3, minus 5 equals our g of x. Okay, again, it's factor of 1/3, it's horizontal, so it's the inverse, so it's a reciprocal. Reciprocal of 1/3 is 3, it just affects the x, so it goes inside. The second one says that we're going to do a function h whose graph is a vertical stretch of the graph by a factor of 2. Again, vertical affects the whole thing, so we have to go 2, and then in parentheses, the absolute value of x minus 3 minus 5. And so that becomes distribute that. Now you don't distribute into the absolute value, you just write it like this, because you have to do the absolute value first. Minus 10 would be our h of x. So that would be both a horizontal, in this case shrink, and this would be a vertical stretch by a factor of 2. So again, now I'd like you to try the monitoring progress, numbers 5 and 6. So go ahead again, pause the video, go through and do that, then come back and see if you did it correctly. So, on example number 5 here, it says f of x equals 4x plus 2. We're going to do a horizontal stretch by a factor of 2. So remember, horizontal goes inside, and it's the inverse of what it says. So you should have, this 2 becomes 1/2. And then it just affects the x, so it would become 4 times 1/2 x plus 2. And now you should simplify that. We multiply by 4. 4 times 1/2 is 2x plus 2. And that was a g of x. And then the next one, we were supposed to do a vertical shrink by a factor of 1/3. So remember, vertical affects the whole thing. So we just go 1/3 parentheses and put the whole function in. Absolute value of x minus 3. Distribute that. So we get 1/3 the absolute value of x. And 1/3 times -3 would be, again, when you multiply fractions, right? You multiply the numerators together and the denominators, so that becomes a -3/3 or -1 would be our g of x. All right, so back to the notes. We did the MP 5 and 6. So here's kind of a summary of everything we've covered. So, our summary. If the value affects the x, so just the x, then we know that it's horizontal and it's the inverse. So if it's added, it's the additive inverse or opposite. If it's multiplied, it's the multiplicative inverse or reciprocal. But if the value just affects the x, it's horizontal and it's the inverse. If the value affects the whole thing, the whole f of x, then it's vertical, and it is what it says it is. If it's added or subtracted, then it's a translation. Okay, all the addition subtractions are translations, either horizontally left and right or vertically up and down. If it's multiplied, then it's a stretch if a is greater than 1. It's a shrink if a is between 0 and 1. Again, remember, if it's horizontal, it is the inverse of what it says. And then always remember negative signs or reflections. So the last thing we're going to look at is number 4 on page 15 in the textbook. So we're going to look at combining transformations here. So it says let the graph of g be a vertical shrink by a factor of 0.25 followed by a translation 3 units up of the graph of f of x equals x, and write the rule for g. So what you do is you just take it one step at a time. So we've got this function f of x, which they don't even tell us. Actually, it tells f of x equals x. Okay? So all you do is you take it one step at a time. It says let the graph of g be a vertical shrink by a factor of 0.25. So vertical affects the whole thing, so that would be 0.25 times the function, which is x. So we took care of the first one. Then it says followed by a translation 3 units up. Well, again, 3 units up is vertical, so it affects the whole thing. So we add 3, and we're done. Now, where it can get confusing sometimes is it depends on the order things are written. If we did this same problem, but we did it in reverse, if it said do a translation 3 units up and then followed by a vertical shrink of 0.25, it would look a little bit different. Because if I did that, the first thing I would do is add 3, right? And then I do a vertical shrink of 0.25, well, that vertical shrink affects the whole thing. So my answers are not the same because the order in which we were supposed to do it. So they're going to combine transformations on this. Your assignment is on page 16, 1 through 39. Again, this will be put onto the Google Classroom, and the assignment will be on there. This is the key, is the summary. Okay, if we can understand if the value is affecting the x or the whole function. If it's affecting the x, it's horizontal and the inverse. If it affects the whole function, then it's vertical. And again, you can do the same thing the other way. If it's horizontal, we know it's affecting the x, and if it's vertical, we know it's affecting the whole function. If it's added or subtracted, it's a translation. Multiplied is stretch or shrink. And negative signs do the reflections. Okay?